Today you will see a first prototype of continuous governance on our Mythos blockchain, a type of governance where a proposal has multiple options and the vote never finalizes. Instead, you have voting thresholds. Take this graph. In a proposal with multiple options, we only take the two options, option 0 and 1, with the most votes. And these lines are the thresholds. Here in this area, we are above the threshold line in option 0. So at this point in time, option 0 on the y-axis has the most votes. And at this point in time, it was declared the winner. But then we see how option 1 on the x-axis gains more votes and passes its threshold. So at this point in time, option 1 wins. And then option 0 starts getting even more votes and passes its threshold here. So at this point, option 0 is again the winner. And after this moment, option 0 remains the winner because it remains beyond the threshold that would switch the vote. Variations of this algorithm that we have created are now used for Mythos governance. Eternal voting is best suited for decentralized constitutions, in other words, for eternal principles. But it is also suited for practical choices in the lifetime of a blockchain, like the consensus protocol used, various economic mechanisms, or for choosing the type of elected officials that a decentralized community may have. And we have implemented this type of governance as a WebAssembly smart contract. As you know, Mythos is built on top of the Cosmos SDK API and is compatible with any Cosmos chain, and it runs WebAssembly contracts. Previously, we have ported the Cosmos governance module as a WebAssembly contract, and now we are creating new types of governance. In a continuous voting model, a proposal has multiple options, and each option can have several messages that can be executed by the chain. And I have a local Mythos chain running here and a UI here that can interact with the governance contract. So let's create a new proposal. For each proposal, you need to stake a type of coin, and we will use Myth. These are some coefficients for the thresholds that we were talking about earlier, but they can only be set if we have arbitration points. So let's give our proposal a title. Let's choose the name of this current blockchain. And we can set here any URI that we want, but we will just set, for example, the website for a forum discussion. And here we can write a summary of the proposal. And our first option for this proposal is Mythos. We can also have a separate URI for discussing this. And an option summary. Okay, now we register this proposal, and it is a contract execution message. And we should already see that our governance module has executed this proposal. So it's proposal with ID 3, and the winner is option 2. So what does this mean? If we go to all our proposals, we can see our new proposal here. So this is the third proposal with ID 3, and it has 3 options. So let's choose it. And we can see our proposal here with title, summary, and a graph with the 3 options, because each proposal has 2 default options, status quo and unenforceable. And our Mythos proposal is the 3rd one with ID 2. That's why we've seen that proposal with ID 3 was executed and the winning option had ID 2. And we can also see the next voting threshold at which the next option will win in case it's a different option than our Mythos proposal. So let's create another option for WasmX as the blockchain name. WasmX is the name of our WebAssembly engine for smart contracts. So we give a short description of why, and we can also have a URI here, either a URL or another decentralized identifier. So now we propose this option, and at the same time we vote and stake this amount of might. And we see that we have voted enough to trigger another change. So now proposal 3 has successfully executed option number 3, which is our new option that we have added. And we can see that the graph has changed. There is a new option added here, and we have our WasmX title proposal. And we also see the transaction hash and receipt for our new option. So let's add one more. And we can see our 5th option here with ID 4, Concordia. So we have 2 options that has the same amount of votes, and let's vote on one of them. We'll select our last one. And we have another execution for option with ID 4 for our proposal with ID 3. So now 99.8% of the vote goes to our last option. And so on. We can vote until the next threshold is passed and the outcome becomes more and more stable in time. And this way you can immediately make choices for the governance of a chain that can be reviewed continuously by the community once more people are introduced to the system. And this type of governance is made to be partially compatible with Cosmos SDK governance. So in a Cosmos Explorer, for example, we can see this governance proposal here with the name, and of course the proposal will not end, it doesn't have a deadline, so it has a very big voting deadline shown here. And Cosmos Explorers can read governance data, but we can only see the most voted option and the second most voted option here, shown as yes and no. You have seen continuous voting as a core governance mechanism for a blockchain.